All right, do you need me to review either how to find an angle or a side of a right triangle with your basic SOHCAHTOA stuff? We're all good? Nobody? Okay. What? Maybe? Okay. Oh, we already talked about this in this class. Didn't I remember to talk about?
Yeah.
Okay. What about, need to talk word problems maybe for a second? Because the pictures aren't drawn, okay? It says an airplane climbs at an angle of 18 degrees with the ground. So ground, plane climbing. I'm just going to draw it with the ground. Is that okay? You could draw it in the sky parallel to the ground, but find the ground distance. So we're looking for this X down here. Does that make sense? The plane travels as it moves 2,500 through the air. Where's the plane? It's on this hypotenuse, right? I can't draw a plane, so it'll be really bad. Just warning you. There we go, plane. Okay. So this is 18 degrees, and the path the plane has flown is 2,500. Okay. So we want to use what function? Adjacent and hypotenuse. So we want to use the cosine of 18 degrees equals x over 2,500. Multiplying or dividing? Multiplying, and we want to make sure our calculator is in degree mode for this whole quiz, okay? Mode, degrees, 2,500, cosine of 18. I got 2377 or 78, because does it say round to the nearest meter on this particular question? Yeah, 2378. Any questions? Okay. A damsel in distress is in distress and is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder when the knight stands 15 feet from the base of the tower. Okay, so here's our tower. And he's 15 feet away and looking up. Angle of elevation is 50. Where's that go? Well, so this is 50. Can't be with a vertical line ever, 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 right? Angle of elevation is actually from where he is usually looking up, okay? But if you put her angle of depression looking down, isn't that the same thing? I don't know why my hypotenuse isn't touching the tower. I didn't draw it well. This is 50 degrees. How long does the ladder have to be? So what are we looking for here? The hypotenuse. So cosine again equals adjacent over hypotenuse. What's different this time though? Yeah, we're going to do 15 divided by the cosine of 50. Are you about done? Okay. Someone get an answer? $23.3. You might want to get a 24-foot ladder, just saying. Whatever. Okay. Those are not identical to the two that are on the quiz, but you get the idea. You have reviewed angle of elevation, depression. We're okay? All right. Special right triangles. Do we need to review any of these? The first one is kind of ugly. This is a short leg. So what do we do to get this long leg over here? Short leg times square root of 3, which is a lovely square root of 18, or 3 square roots of 2. That was a lovely mess. Okay, so that's V. And what do we do from the short leg to get to the hypotenuse? We times it by 2, so we just get 2 square roots of 6. I don't really think there's one quite that ugly tomorrow. Okay, 4. I could be cruel and put this on. Because this is supposed to be leg, leg, and leg square roots of 2, right? So if 6 is the leg times the square root of 2, we get 6 square roots of 2 over 2, which is 3 square roots of 2 here and here. Everybody okay? If you need more practice on special right triangles, just let me know. I can give you lots of worksheets on that. Otherwise, the remediation for this entire quiz is already in the bucket if anybody's freaking out about a section and wants to practice extra tonight. All right, so this is an easy one. What do we get? 7 and 7, we okay? All right, this time's pretty easy too because we get a hypotenuse. So what do we do to get the short leg? Divide by 2, so this is 4, and this one is 4 square roots of 3. Can you just use trig on these? You could, but you'd have to use your unit circle and exact answers, right? You can't use your calculator, okay? What am I talking about? Well, I suppose if you wanted to do number 6 and say, I want to find, let's see, this would be opposite and hypotenuse, right? The sine of 30 equals y over 8. Everybody good? What is the sine of 30 from your unit circle? It is 1/2. So now could you solve and find y is 4? Okay. No, you can use calculator on the quiz. No, what you have, I would just use your special right triangle patterns. Okay. So I wouldn't do this. Well, there's just this. Yeah. Okay. Moving on. This is on the quiz, and this is a little more like, honestly, you could use your unit circle and I wouldn't know the difference. But the way you're supposed to do this is if the hypotenuse is 6, the leg is 3, so this is 3 square roots of 3. Did I skip something that's on the first page? Oh, maybe. Maybe I made a... Oh, okay. I'll figure that out in a second. Yeah, I'm going to keep going on this question right now. So this says find the secant. So from this 60-degree angle up here, that's the flip of cosine, right? Cosine is adjacent over hypotenuse. But I need to do what? Flip it over. So it's just going to be 2 or 6 over 3. All right, cotangent is what? Instead of opposite over adjacent, it's adjacent over opposite. So from here, adjacent over opposite, what's that going to become? Square root of 3 over 3. Could you have used your unit circle and found what the secant of 60 and the cotangent of 60 are from just your unit circle? Yes. I'm not going to know the difference, okay? What about this one? 5 square roots of 2. So the sine of 45 from here, opposite over hypotenuse, is what? It's 5 over 5 square roots of 2, which reduces to 1 over the square root of 2, which is square root of 2 over 2, which is sine of 45 from your unit circle, right? Okay, secant of 45 is flip over the cosine, so it should be hypotenuse over adjacent, which would be 5 square roots of 2 over 5, or just square root of 2. All right, so let's. All right, guys, so somehow I skipped this. What did I just do? I don't know what that is. All right, so is this what you have at the bottom of the first page of the review? All right, what do we have to do? We have a 6 and an 8 hypotenuse. 6 squared plus 8 squared equals hypotenuse squared, and we get 10. Okay, it says up here to find all 6. The quiz asks for 1 or 2 specific ones. It doesn't ask for all 6. I'm just telling you now. Let's go through this 6 really fast or not? Do you not need me to? Okay. Sine, cosine, tangent, cosecant, secant, cotangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Yes? How we doing? Did I get them right? All right. This question, what do we have to do here? Boop, gone. See how I do that? All right. What do I have to do, guys? If you're me, yeah, you just draw a right triangle. Tangent is opposite over adjacent. I don't think this is coming out nice, is it? 81 and 169 is 250. No, it doesn't round up. You have to find exact answers. Square root of 250 is the square root of 25 times 10, so 5 square roots of 10. Did someone get that? Okay. Do I need to do all 6 functions? It's going to ask for 2 or 3 of them, okay? What if I do sine? Nine over 5 square roots of 10, which would become, be careful, 9 square roots of 10 over, what's this going to be? 50, and that doesn't reduce. On the quiz, it just says to find a couple. For the review, I figured we would find all of them, but are we good? Yeah, on the quiz, you never have to find all 6 because I don't want to grade all 6. Do you need more practice on anything there? Okay. Then we're at converting. Okay. If it's negative, what do we have to be careful to do? To find a coterminal one. But if we want to just change it over into degrees, we just need to remember to leave it negative, right? Because it was a negative angle to start with. You can just cancel this and then type on your calculator 5 times 180 divided by 12. I'm thinking it's 2 negative 75. Is that right? Okay. What are we doing with this guy? Nope. We're not fine. Guys, all it asks you to do, got to read directions carefully. I'm pretty sure a bunch of you are going to get things wrong because you don't read directions. All this wants is convert into radians. Don't find a coterminal angle. Don't tell me the quadrant. Don't, okay? Just convert into radians? So multiply by pi over 180. Yeah, I don't have a clue. What's 465 divided by 180? Math, enter, enter. Yes? That's nice, disgusting answer. Glad we have a calculator that reduces. All right, do you remember how to do these? Where's the button? Okay, second, okay, on first is good. Second, apps, okay? And it's choice 4 here we're going to use. But first we're going to go to the home screen and do, what was it? 213? Oh my goodness. 213.395, and then that second apps into degrees minutes second thing. I got this answer, yes? 213 degrees, 23 minutes, and 42 seconds. Got to write the whole thing, okay? Does anybody remember how Hofbauer does this one? 60 plus 45 over 3600, because I don't like finding all those buttons. But if you want to find all those buttons, it's 79 angle degrees 3 app choice 2 for minutes, and then 45 what? Alpha plus to get the quotes. Okay, 79.0625, and don't round, okay? It should come out such that you give me the whole thing. If it did come out past 5 places, you could round to 4, but don't do any, otherwise it's not equivalent. All right, is this the next one you have? Okay. The gear in a machine has a radius of 4 inches. R equals 4 inches. It's running 1750 RPM, stands for what? Rotations or revolutions per minute, same difference, I don't care. Okay? First thing you have to do, change it to radians. So 1 rotation is 2 pi radians. Then what? Yeah, eventually we're using this, in my mind anyway. And we just figured out this mess is the angular velocity. So now we need to multiply by the radius, which is 4 inches. Okay, but then we also have to do, according to this, some converting. We need to say 12 inches is 1 foot. Okay, so I'm typing 1750 times 2 times pi times 4 divided by 12 when I'm typing. Somebody have an answer? 0.5? What, 0.9? So 0.2 feet per minute. I can't squeeze that in there. Yes, no, anybody not getting that? Okay, there is one of each of these, find an area and an arc. Those are supposed to be easy, but if you didn't do your homework, you haven't seen one. How do you find length of an arc? That's area. Find length of an arc on your pink sheet, guys, so you know where to look tomorrow. S equals R theta, and theta has to be in radians. Now, maybe I was nice and gave it to you in radians. If I'm not, you have to convert, right? Multiply by pi over 180. Okay, this one is in radians. So we just do 7 inches times 3 pi over 4. You can give me either an exact answer or a decimal. It's 21 pi over 4 inches, or anybody have a decimal? 20 something maybe? Oh yeah, because I'm dividing by, okay, yeah. Either one is fine with me, okay? Are we good? Okay, area of a sector, what's this formula? 1/2 r squared times theta, again in radians. So what do we have to do this time? Okay, we have to make this 225 times pi over 180, or what is that, 5 pi over 4? Okay, but you don't have to reduce if you don't want. You can just type it in. Okay, I could make this 0.5. I could make this 14, and I could just leave this 225 pi over 180. Type it in, or you could give me an exact answer, but it's going to be an ugly exact answer. Check that you've typed it correctly. Look on your screen. Make sure you didn't do something wrong. I got 384.8. Anybody? Label? Miles squared, because it's an area. Okay. Okay, guys, right over here it says give exact answers or to the nearest tenth. Remember, formulas require radians, and it says label your answers. If you forget, like in this whole section, if you forgot one label, I might let it slide, but if you forget multiple labels, you probably get a 4. Okay? That seem okay? All right. Find the quadrants. Find the quadrant. We could also practice reference angles while we're here, but the directions say find the quadrant. Okay, what do you want to do first? Oh, does it on yours? Yeah, I think I did 2 of the, oh, yeah, we should do quadrant and reference angle for practice, okay? Okay, how do you do quadrant? Most of us change it to degrees, yes? Okay. 600, did anybody get 600? So if we subtract 360, we're at what, 240? Which would be quadrant 3. Okay, if we drew a 240 in quadrant 3, the reference angle would be minus 180 would be 60. Okay, it didn't ask for that, but that's the reference angle. I know there's some on the quiz where you have to do reference angle. If it asks for reference angle, it's a multiple choice, I think, because I tried to make it easy to grade. But if it's reference angle, it started out as radians, so you'd have to do what? Put it back into radians. This would be what? To find the quadrant? Or okay. Anyway, the reference angle, what are we doing here? 174 is quadrant 2. The reference angle, if it asked, would be 6 degrees, and that one was in degrees, so we didn't have to do anything with it. We good? All right. This is using your unit circle. We did a lot of this yesterday. All right, 7 pi over 6. I don't know what that is. Is that someone's phone? 7 pi over 6 is here. If we want the sign, it's negative 1/2, yes? Everybody got out their pink reference sheets doing this? We're good? Cotangent at negative 5 pi over 6. What is the, where am I at for negative 5 pi over 6? 5 pi over 6 is to here, so negative 5 pi over 6, same spot, right? And what are we asking for? Cotangent, which is x over y. And remember, you can, keep going the wrong way, sorry. This is x over y. And you can ignore your denominators because they will cancel out. So we get positive square root of 3. Is that right, guys? Okay. Sine negative 180. Well, 180 is 180 whether you went positive or negative. So we're here. What's the sign? The sign is just the y coordinate, right, guys? We don't need to flip it over or put it over anything, so it's just 0. I'll get it right eventually. Okay. Negative pi over 4. The coordinate should be square root of 2 over 2, negative square root of 2 over 2. Is that right, guys? Cosecant. 1 over sine, so it should be... No, I have them far on the bus. If you have time to proofread, make sure I didn't put any room numbers on there transposed or anything. I never did check it. I did check what happened. Okay. We're flipping this over. So it's 2 over negative square root of 2. What is that going to become, guys? Negative square root of 2. All right, sine negative 840. What are you going to do there, Patrick? We're finally going to add a couple 360s. Actually, if we add 3 of them, what do we get? Positive. $240? That's what I got. Okay, I got that it's the sine at 240. So if we go to 240, the sine is just the y coordinate. So it's negative square root of 3 over 2. Anybody lost there? 5 pi over 4 writes on our unit circle, right? What's the sign? Negative square root of 2 over 2. Cosecant of 0. What's the ordered pair at 0? Okay. Cosecant is 1 over the sine, which means it's 1 over 0, which is undefined. If you leave it 1 over 0, have I said this 1,000 times? It's wrong. Okay, you have to tell me it's either 0 or 1 or undefined or whatever it simplifies to. All right. Cotangent 840. 120. If we subtract 360 twice, we get 120. Okay, the ordered pair at 120 is negative 1/2 positive square root of 3. Did I do that right? Without looking? Is that the right ordered pair for 120? Okay, cotangent is x over y, so I get negative 1 over the square root of 3, which is negative square root of 3 over 3 when we rationalize. Okay, again, if you need more practice on this, first of all, I have extra copies of the practice warm-up we did yesterday, okay? But there's also a remediation worksheet over there, if this is concerning you. Are we good? All right. Last little section here, find the reference angle. We could also talk about quadrants, but guys, does anybody know right away by looking at this what the reference angle is? Nobody's got a guess? What? Yeah, but we need it in radians, so it's just pi over 4, okay? It's just pi over 4, but if we, most of you probably would have changed it to degrees. 8100? Is that what you get? What did I do? Oh, I forgot to divide by, no. Okay, just don't even listen to me. So if you subtracted 360, you'd be at 315, whose reference angle is what? 45, and then you'd have to change it back to radians. Are we good? What quadrant was that in? Just for extra practice. It was quadrant 4 because it was 315, right? All right, reference angle here. Well, if you added 360 twice, you'd have what? 15 degrees. So if you went this way, it would be 15 degrees. What's the reference angle then? 15. Everybody okay? Nobody's saying anything, so okay. Negative 167 is down in this quadrant, right? Quadrant 3. How do we find the reference angle? Yeah, we need this angle in here, so I would just do 180 minus 167, or you could do negative 167 plus 180. What is it? 13? When you go to tell me a reference angle, what do you have to make sure? It's positive and it's less than 90, okay? And it's the angle it makes with the x-axis. Any other questions? Oh, quick. There's one like this. You know what? Can we just decide what quadrant we're in, or maybe draw the triangle for a couple of them? Okay? We don't have to find them all, right? If we can draw, you can find them if I can help you draw the triangle. Okay. Sine is positive, cosine is positive. Everybody knows that greater than means positive, yes? Greater than 0? Okay. So what quadrant am I in? Quadrant 1. So I'd have tangent is opposite over adjacent. I'd do Pythagorean theorem. Okay. This one is positive, negative. That would be all students take calculus. Sine is positive, so it would be students in quadrant 2. Okay, quadrant 2. Cosine is negative. Then you would have, if you flip this over, you'd have the sine is 1/2. So you'd have 1 and 2. You'd get square root of 3, negative right there. Cosine is positive and sine is negative would be quadrant 4. Okay. Sine is opposite over hypotenuse. This is negative. You'd get square root of 24. Sine is negative and cosine is negative also would be quadrant 3. Negative 12, 13 would make this negative 5.